Hello, and welcome to this short video series brought to you by 3DBuzz. My name is Lee Renaud, and today I'll be showing you how to make a simple 2D sprite demo using Unity 3D and an add-on script called SpriteManager that was written by Brady Wright. What we're going to be doing is just putting together a real quick demo that demonstrates sprites, some physics, and this little level of slanted floors. Nothing much, but just enough to give you an idea of what can be done if you want to build a 2D game using sprites. The reason I'm putting this together is a lot of people think that Unity 3D is only for 3D and that you can't create 2D games with it. And in fact, that is actually not true. It can be done, and there's two different ways that you can go about doing it. One is actually to just use Unity itself without any add-on scripts. And I'll be showing you how to do that and the advantages of why you would want to do that and why not a little bit later. The other thing that I'm going to be showing you in this series is how to use SpriteManager. Now, SpriteManager is actually a series of 3 scripts that was written by Brady Wright over at Above and Beyond Software. His current version, though, is SpriteManager 2, which just came out a couple months ago. And with this version, it has a whole lot of new features added in. You can come to his website, which is anbsoft.com, and go to the Sprite Manager section and take a look and see all the new features. Something that's also new with this version is he's actually charging a single user or a studio license fee. Single user is $75 and $275 for the studio license. What we're going to be using in this demo, though, isn't going to be SpriteManager 2. We're going to be using his initial SpriteManager, the very first version that he developed and documented a lot of over in the Unity community. So I'm going to take you over there and show you where we're going to get our scripts. So what we can do is go to the Unify community wiki, which you can see here, and the scripts that we're going to be using are actually located under the scripts, and we scroll down to performance, which is down here, and then SpriteManager. Now, this wiki entry has got a lot of documentation about how to use the SpriteManager, which we're going to be using just some of the very basic functionality that's built into the script, just to get it up and running so you can get a feel for it. I'm not going to get into any of the animation that's built in or any of the UV offsetting or the billboarding. We're just going to use the very simplest functionality to show a sprite. Now, you may be wondering why would we want to use SpriteManager at all, since how I said we can actually do sprites inside of Unity without this add-on. The reason we want to do it is a couple of different reasons. The most important reason is to save on draw calls. Now, a draw call is basically every time the Unity has to go out and put together a bunch of elements in a scene and draw it, and then composite that with another draw to build the final scene that you see on the screen. That is a draw call. Now, in the PC world, draw calls aren't going to be so important because we have these really powerful computers with uber powerful GPU graphic cards that can handle lots and lots of draw calls, and you'll never notice the slowdown, and your games will be running at 30 or 60 frames a second, and it's not an issue. Now, if you're trying to build a 2D game for an iPhone, that is an entirely different matter altogether. With an iPhone game, you've got a very small processor that can only handle so much fill rates and refresh. So to get your game on an iPhone to run at 30 frames a second to be acceptable, you have to keep your draw calls as low as you possibly can. A good benchmark is to stay under 15 to 20 draw calls. Anything more than that, and you're going to likely cause your game to come to a screeching halt or run at just a couple of frames a second, which is not going to be very fun. That's where SpriteManager comes in. By using SpriteManager, you're able to batch all kinds of different sprites together into a single draw call. Now the argument is with the new iPhone Unity 1.51, we have dynamic batching, and if you have the advanced version, you have static batching. And that is true. There is that functionality built into the new Unity, and you can definitely take advantage of it. But some of my testing that I've played around with and just doing some number crunching, it shows that while it does do some batching and it does save you some time, it isn't quite as efficient as you get with the original SpriteManager. Case in point, the example that we're going to be building with just the 5 basketballs bouncing. If I was building this on the iPhone Advance with dynamic batching, it would crunch the numbers down to about 2 to 3 draw calls, depending on the transparency and a couple of other issues. And it's batching about 10 objects, which are basically each of the individual elements. And I'll discuss how we can even trim that down, and one for each of the basketballs. Now, when you use SpriteManager, you render at 2 draw calls, and you actually only have 5 batch objects, which is the background, because the SpriteManager is its own object that doesn't get batched. So the numbers there, you have less objects that are actually being batched, which is a good thing. It's less processor overhead that has to be dealt with on each frame, and the draw calls are about the same. So you're going, well, don't really need that overhead, then why do I need to learn SpriteManager? The advantage of SpriteManager is above and beyond just the draw calls. Advantages that you get with SpriteManager is the fact that it actually has code built in that allows you to do sprite animation. It has the ability to use texture atlases. So you can use one texture and have the textures that you need for many, many different game objects all held together in an atlas. So you could have, say, an entire level of objects in your game that use only one texture, and you just use the UV offsets to display the texture on the right object, in this case sprites. If you wanted to have a little character running around, you could actually use a single texture and draw what used to be called a sprite sheet. You could draw your individual sprites in different positions on that texture, and then use SpriteManager to keep track of what frame of animation and what offsets need to be used to update that sprite on the object that's being drawn to the screen. So that functionality in itself makes SpriteManager worth doing. And I will probably have a series later that shows you how to use sprite animation. We're not going to be getting into it with this one, as all I really want to do is show you how to get SpriteManager installed, set up, and how we can use it to just put a simple texture on a ball and have it react inside of the world. With that being said, I'm going to wrap up this video, and when we come back in the next video, we're going to start setting up the project, and we'll get this thing going, and so you two will know how to make this type of demo. See you next time. Welcome back to the second video in this series. In this video, all we're going to be doing is setting up the framework for our project from which everything else is going to be built. We're going to keep it real simple, and with all these videos, my intention is going to be to keep them as short as possible, so anybody that is coming in can jump to just the videos that they need if they're already familiar with Unity and how to set up projects or any other part of it. So let's get started. The first thing I want to do is create a new project. So I'm going to open up a new project, and I'm going to browse. I'm I'm going to go to my C drive under Files, Projects, and I'm going to create a new folder here, and I'm going to call this folder Sprite Demo. Select it. Now for this project, I don't need any packages pre-installed. I just want a blank, empty Unity project, and we'll start off with that. So now Unity, for some reason, has started giving me these errors, and rebooting it hasn't fixed it. I'm not quite sure what it's about, but Unity seems to work anyway, so I'm just going to close and ignore it. Now, like I was saying, with these videos, I want to keep them short and simple. So this is not going to be an in-depth explanation of what Unity is and every feature inside of Unity and how to use it. For that type of information, there are excellent resources both on 3DBuzz, particularly the 29 videos that Jason Busby did on creating a simple 2D game. And of course, the Unity community has tons and tons of examples through the forums and the wikis. There's all kinds of information there if you want to read and get a better understanding of the basis of Unity and how it works. But for this, we're going to be going really fast and just an overview of everything. So what I want to do is I want to start creating some folders. My very first one is going to be scenes. This is where I'm going to save all my scenes that we're working on. Next one I'm going to set up is going to be scripts. Third one, materials. Fourth one is going to be textures. Whoops, did not save. And the fifth and last one is going to be prefabs. Like I said, short and simple. All this video is just setting up the folders, saving the project. The last thing that I want to do is save our scene before we finish. And I'm going to save it under scenes, and I'm going to name the scene demo. Hit save, and with that, that's all I want to accomplish for this video. In the next video, we're actually going to go to the Unify community, to the SpriteManager wiki part of it, and we're going to retrieve and set those scripts up and get those in place. I shall see you next time. Welcome back to the third video in the series. In this video, and actually the next couple of videos, we're going to be bringing the SpriteManager scripts over from the wiki and getting them installed and functional inside of Unity. So let's get started. To start, inside of scripts, we're going to create a new script, a C# script, and we're going to rename it. We're going to rename it SpriteManager. And I'm going to hit enter. From here, we need to create a project for our code. So I'm going to hit Sync Visual Studio Project. I should also mention that I'm using the Windows version of Unity right now, and I'm using Visual Studio 2008 as my editor. Now, in some other videos that we're currently working on, we show you how to set up your own script that will create a code project that you can use in either Visual Studio or MonoDevelop for the iPhone version of Unity, which does not have this functionality built in. If you're using the Mac version of 2.6, I believe it does have the ability to create the project and allow you to open it up in mono development, but the iPhone Unity right now does not. So with that being said, and after I've already synced the project, we can go ahead and open up the SpriteManager, and it'll fire up Visual Studio, and I'll bring it in. Now it's already brought in my SpriteManager CS file and given me some initial code, but this code is not what we need. We're going to actually end up removing all of it and replacing it. What we're going to replace it with is actually going to be the code from the SpriteManager section of the Unify Communities wiki. And you can go to unifycommunity.com, go to their wiki, and if you're just getting here, you didn't watch one of or the very first intro video, that's actually going to be held under scripts. Scroll down to Performance Sprite Manager, and that will bring you into this page. Basically, the first part of it is a description on how to use the scripts and all the functionality that's built into them, with a basic introductory description of how to use them. And as we scroll further down, we'll eventually get to the beginning of the very first section of code. This is the code that we need for our very first CS file. In here, you've got the credits. I highly recommend leaving the credits in there. I mean, Brady Wright did spend an awful lot of time developing this, so give the guy his due and just keep the credits in there. It's not going to hurt anything. Now, if you scroll down through here, you'll see some additional classes. The UV animation, this is what helps hold the information for controlling sprite animation based on UV offsets. And let's see, we can scroll a little bit further down. We eventually get to the Sprite Manager itself, and some of its functionality. If we scroll further down, you can see pixel space, the UV space. These are helper functions, or sorry, yeah, helper methods. And eventually we get down a little bit further. You can actually see some of how Sprite Manager works. In here, you can see where it's actually creating vertices. And let me scroll down. Basically, what Sprite Manager is doing, and the way it works is its magic is it is creating geometry on the fly for you. So when you create a sprite inside of Sprite Manager, what it's doing is it's building two triangles to make up a quad. And it has to make triangles because the iPhone version of OpenGL and OpenGL at its core supports triangles. You use two triangles to make up a quad, so you end up with 4 vertices to a quad, and that's how it gets its information. Now what happens is Sprite Manager is kind of slick in this way. At its core, what all it's doing is every time you say make a sprite, it is taking the location of the object that you've assigned to create that sprite at. It's taking its transform and creating a sprite at that location. What Sprite Manager then does is it assigns a quad and creates 4 vertices, and which make up the 2 triangles, which make up the 1 quad to represent that sprite. Then it takes all of the sprites that you've assigned, and it takes all of those triangles and assigns them into one mesh. So at the end of the day, after you've created all of those sprites, you have just a single mesh that contains all of those triangles. And then it takes your texture that you've sent to a material and assigned to the Sprite Manager, and takes the UVs that you tell it and maps that texture and those UVs to those quads. And I'll show you, and you'll see more of how that works in more detail when we actually start setting up the Sprite Manager object and assigning the materials to it, and I'll go over it. So I just wanted to go over the basics of what it is actually doing. And that, like I said, you can read further on it and actually rip the code apart if you want a better understanding. That's just a very gross overview of what's happening. Now, back in Visual Studio, we've copied the code from the wiki, and I've back here to my Sprite Manager CS file. I'm going to take all the existing code and I'm going to remove it, and I'm going to paste in the code from the Sprite Manager. So what I'm going to do is, now it's all copied in, I've removed the old code, and I'm going to hit save. And then from here, I can go back in and we can see that the new code has updated. You'll also notice down here that it seems to be broken because it can't find the a type or namespace called Sprite. The reason that is because we haven't included that script into this yet, so it's looking for something that we haven't put in yet, but we will get there. And from here, we've got that. And that's pretty much all I wanted to cover in this video, was how to get this Sprite Manager in place. In the next one, we're going to bring in the next script, which is called LinkedSpriteManager, and I'll go over what that is and why you want to use it in the next video. So with that, that's the end of this video, and I'll see you next time. Welcome back. In this video, we're going to continue on bringing in the SpriteManager scripts and getting those set up. The next one that we need to work on in this video is actually going to be the LinkedSpriteManager. Now, there's two ways you can do it. We can do it the same way as before. We can come in here and we can create a new C# script and erase it all. Or we can also come into Visual Studio. Now that we've got a project all set up and synced, we can actually come into Scripts and hit Add New Item Scripts. Now, give it a second, it'll open up. In here, the way I'm going to do this is going to be a little bit different. I actually have templates that I've built for Unity. Now, if you've watched Jason Busby's videos on his simple 2D game, he goes through and describes the process of how you can make these. And they actually do save a lot of time when you're creating a lot of Unity scripts, and it's well worth watching those videos and learning how to do it and set this up on your own. So what I'm going to do is I'm going to name this file LinkedSpriteManager.cs, and I'm going to hit Add. And then this is just going to come in here. It's going to create my base class and get it all set up. But just like Sprite Manager, this code is not needed, and I can actually delete it, because the code that we're going to use is actually over here in the next section of the wiki. And again, I'm going to copy all the code, including the comment section, to give Brady Wright his credit. And we're going to come down here, and if you look, LinkedSpriteManager is nothing more than an extension of the Sprite Manager, which means it inherits all the functionality of the original Sprite Manager, but then adds some more functionality on top of it. Now, what functionality does it add? Well, what it does is it provides a way to update the information based on the position of your object. What that means is the problem that you have is with Sprite Manager, if you were to create a sprite and set it all up and link it to a game object, say an empty game object that has its transform information, that sprite is going to draw at that position of that game object when you start running the game. But what happens if you move that game object? If you decide that that game object's position changes during the game and you're only using Sprite Manager, that sprite isn't going to move along with it. I will also be demonstrating that in a future video. But what will happen is the sprite will draw at the initial position of that object, and when you move that object, that sprite's still going to draw at that position. It's not going to move, but the game object may be moving all over the screen. You just won't ever see it. Now, what this LinkedSpriteManager does is it goes through and it will update the position of the sprite to match the position of the game object of which it's attached. That is very, very handy and reduces a lot of overhead that you have to worry about going in and making sure that you're saving the references to the game objects and then transforming that sprite's position based on that game's object's transform. The downside of it is it can be very, very inefficient if you go, well, I've got all these objects and I don't want to have to deal with it, so I'm just going to attach everything to a LinkedSpriteManager. But what happens if, let's say, for instance, you're working on a 2D side scroller and you have a whole bunch of these blocks that are all over your level that are making up all the platforms that you're jumping. But they stay in one place and they don't really move. Well, if you have the linked sprite manager used for all of them, it is looking and it's going to calculate and check those transforms to see if those objects moved every single frame. And if those objects aren't moving, you're wasting a lot of processor power by using the linked sprite manager. So in that case, you're much better off to use just the sprite manager because those objects aren't moving. Now, in our case, where we're going to have 5 basketballs moving, and they're going to be moving every single frame all the way up until they come to a rest at the very end, and I don't have to worry about some objects moving and some objects not moving, it's going to be advantageous for us to use the linked sprite manager, and that's what we're going to do. But when I get ready to do it, I'm actually going to show you what happens when you use the sprite manager as opposed to the linked sprite manager, and I'm going to show you how you can update the position using the sprite manager in case you're using that as opposed to the linked sprite manager. With that all being said, I've selected all of the text for the linked sprite manager, and I'm going to copy it, and I'm going to switch over to the Visual Studio, and I'm going to come make sure I'm on the linked sprite manager. Come in here, and I'm going to paste all that code. And I'm going to save it, and I'm going to switch back over to Unity. Again, we still have the same error, and we're going to have that until after the end of the next video, because we haven't copied the sprite class over yet. And that is all I want to cover for this video. In the next video, we're going to bring in the last of the 3 scripts, which is going to be the sprite class, and we're going to get that in place, and these errors will go away. And then after that, we can actually start looking at getting some sprites moving on our screen. So until then, I'll see you guys next time. Hello, and welcome to the 5th video in the series. In this video, we're going to finish up bringing over the last of the SpriteManager scripts that we need. So let's go ahead and get that going. I'm going to actually go into Visual Studio, and then I'm going to add new item. Sorry, that's kind of off the screen. But so basically all I did was hit add new item, and it brings up this one, and I'm going to scroll down. Once again, I'm going to use my Unity mono behavior, and I'm just going to call this sprite. From there, I'm going to go back to the website, and then I'm going to copy all of the stuff that is contained inside of the Sprite Script. This script is the one that's responsible for controlling a lot of its animation, its visibility, its layering, and various other pieces that make the whole system come together and work. So I'm going to copy. I'm going to come over here, highlight everything so I can replace it, hit paste, and that gets the sprite up and going. So from here, it's now pasted. One of the things that you at this point should probably verify is your naming. You should look and make sure that the class here, Sprite, matches up with your file name. Also check that in the linked sprite manager. Make sure the linked sprite manager is the same as your CS file, along with the sprite manager. This one though is a little bit different. We have to scroll down a bit to find it. And sprite manager is the same here. If these names don't match with the classes defined inside of them, Unity will report an error and will be rather upset with you. So come back here and notice, like I said, after we got the sprite script in place, those errors went away. So from here, what I want to do is I'm going to hit File. I'm going to save my scene just in case. And then I'm going to do one additional piece, and that is to select all 3 of the scripts, and then I'm going to export it as a package. I'll make sure all of them are checked, and I'm going to hit export, And then from here, you can go into your directory. Let me move this up here so everybody can see what I'm doing. Basically, search down to your Unity folder, editor, standard packages in here, and I'm going to call this Sprite Manager. And then I'm going to hit save. So basically, all we did is we've exported and created a Sprite Manager package. So instead of having to go back with every new project, creating some empty classes and copying that code in, we've now got a package so we can import that package directly from our Unity. So if we go back in, files, program files, back to Unity, into editor, and then we go right down to standard packages, and we now have our Sprite Manager package, which can be imported. So with that, that's all I wanted to show you in this video. In the next video, we're actually going to get started and set up our scene so we can move forward from there. Till then, see you next time. Hello and welcome back. In this video, we're actually going to start setting up our scene and getting it to look like a game. So what we need to do to start is make sure that we get our project set up. Because of the constraints of the recording system that I've got going, I'm going to use the web default 600 by 450 so it will fit nicely on the screen. And the very first thing I want to do with our scene is set up the camera. Now, to set up the camera, mostly we're not doing anything 3D, so I don't really need a skybox, so I'm going to set it to a solid color, and I'm going to change the background to black. That just gets rid of the any additional overhead that might have been incurred with trying to draw a skybox, and black is always a good color. Now, because this is a 2D game and not a 3D game, there's a couple of other things that we want to do. The first is we want to change this into an orthographic camera. Because it's 2D, we don't really need to worry about having perspective drawn, and we want everything to actually not have perspective. Now, from there, we want to set our orthographic size. This is just basically how many units is our camera and our scene. We don't need a very large scene because it's just a small demo, so we're going to go with 5. Now, if you look, this box represents the camera's rendering area. So the camera will show everything that's inside this box. Well, again, this is just a 2D game and it represents as a flat surface. So we definitely don't need 1,000 units of depth. So I'm going to drop that down to about 20, which gives us a nice, nice area. And our near clip plane, we're not going to have anything right on top of the camera, so we also don't need, a 0.3. So we can go with something as far away as 1. So that's what we'll work with. It'll just give us a nice little viewing area, nice little rectangle cube to work with. Now, we've got our camera set up, and I'm going to save here just in case something happens and Unity crashes. I don't lose any of these settings. The very first thing I want to do is get some of our scene together. Now, to do that, I'm just going to start with a very, very simple cube. I'm going to bring my cube in, and as you can see, here's our cube, and he's gray. Now, you may wonder why he's gray. If you're not familiar with Unity, that might seem a bit odd. The reason he's gray is because actually there are no lights in the scene, and we're going to take care of that in a sec as well. But after creating the cube, the very first thing I want to do is zero out his position. So this is going to put him at the very center of the world. And if you look, our camera is set at 1 unit high. I'm going to also put him at the center of the world. So now our cube is at the very middle of our world and in the very middle of our camera. Now let's get some scaling on him. So we're going to scale him out this way some. So let's go with 15 here. His height I'm going to change down to 0.25, and his depth I'm going to change to 5. Because this is 2D, you're not going to see his depth, but because the way our scene is going to be set up for our sprites, the collision is going to be based on a sphere collider, so I actually want to have some depth to this floor plane so the collisions will happen correctly. The next thing I want to do is lower this floor some, and I want to rotate it just a bit so it has some slant to it, just like that. Maybe move them up just a little bit more. Alright, now one of the things that I talked about earlier when creating this was he was gray. Now the reason he's gray, well, he looks gray here, but that's not exactly why. His true color by default is white, but he's gray because there is no camera in the scene. Or sorry, correction, there's no light in the scene, not that there's no camera. So one way that we can fix it is by adding a light. We could add a directional light like this, and then he lights up and you can see his true color, which is white. Now, in a regular game on a PC, using a couple of lights is not going to be that much of a big deal. But when you're working on a very tight budget, resource-wise, in, let's say, an iPhone game, you don't want to use lights if they're not absolutely needed. If you can find a better way to get around without having to use lights, then by all means, that is the way you should do it to save on resource. So we're going to delete that, and I'm going to show you how to achieve the same effect without using a single light in the scene. To do it, we're going to come up here to Materials, and we're going to create a new material, and I'm going to name this floor material, or floor mat. Now, again, the color is white, but let's apply it to our cube. And while I'm at it, I'm going to rename our cube floor. But as you can see, it now has the floor material applied to it, but it's still the same grade. Nothing's changed. That's because by default, the material that is assigned to an object, unless it's assigned another material, is a diffuse white, which expects a light to light it up. We don't have a light, so what you see is just a middle gray. To fix this, all you have to do is come into the shader and select Particle Shader and Alpha Blended. Now the Alpha Blended Particle Shader does not require a light, so you see its full luminosity without having a light. If you want to change the color, you come up here to Tint Color, pick from the color swatch, and that gets us our color. So with a very simple shader selection and applying a material and setting a color, we've achieved the effect as if we actually had a light in the scene. It's a real simple trick. It's very, very efficient, and something that I highly recommend using instead of using lights. Now, with that being said, let's go ahead and add a couple more of these floors. So what I'm going to do is I'm going to just do Control-C, Control-V to make a copy. I'm going to move it up. And in this case, I want to move this one over to about halfway. Maybe slide it up a little bit. And then I'm going to select the bottom floor again. I'm going to hit Control-C, Control-V. I'm going to move it up a little bit. And I'm going to inverse its Z rotation, so it is actually facing the other way. And then I'm going to move it to about here. And this is just mostly just guesswork. Doesn't have to be exactly precise, but it's just something that looks nice. Now from here, I'm going to go ahead and I'm going to create another cube, and I'm going to name this cube wall, and I'm going to apply our floor material to it, and I'm going to set its Z to say 0.5, its Y to 15, and its depth to 5. And then I'm going to position it so it butts up right against that wall. Then I'm Control C, Control V, and I'm going to move it over. And something I missed is I forgot to zero out its, in this case I want to zero out its Y and its Z, because I've already moved it on its x-axis. I don't want to mess with that, otherwise I'll have to reposition it. So I'm just going to zero out the X and Y. Now if I come over here, rotate around, everything should be aligned and all up against the 0 of the world origin on depth. Now in the very intro video I mentioned that draw calls in iPhone development is everything. And with this, if we're to run it, let me save it, and if I were to run it and bring up our stats, you can see that there's 5 draw calls. And I had mentioned in the first video that there's a way that we could reduce this down even further without relying on the iPhone's static batching or dynamic batching. It's a little bit more advanced. I'm not going to actually show you how to do it. I'm just going to tell you a way you could do it. You could actually take this, bring it into a 3D modeling software package like 3D Max, Maya, SoftImage, Blender, some of the many others. You could model this all out as a single object. And then if you model that out as a single object and export it as an FBX and bring it as an FBX into Unity, you'll get the same effect. It'll only be one mesh, and after you bring it in as a single mesh, it will only be one draw call. So, and let's see. Well, it's a good thing I saved because Unity seemed to have crashed. So, like I said, it's good to save all the time. And here at 3DBuzz, one of our guiding principles is to show you everything. So even if something crashes, we want to go ahead and show that process and how we recover from it. So I'm going to close out, and hopefully, there we go, close the program, open Unity back up. File. And because I said before I ran it, I did not lose anything, which is a good thing. So basically, that's all I wanted to show you in this video was how to set up the camera, how to set up the level, and if you're on a tight budget and working with an iPhone, recommend that you design your levels in a 3D modeling program and export them from there and bring them in as a single mesh, so you only take a single draw call hit on it. And with that, that'll be the end of this video, and I will see you next time. Welcome to the next video in the series. In this video, we're going to set up our very, very simple game manager. Now, the reason we're going to set up a game manager is it is a good place to have as the central part for your demo or a game to control all the instantiation of all the other objects, a place to keep some of the game logic, and anything else that you need all in a central location. So to do that, we're going to basically just come up here, create a empty object, and we're going to call that object the game manager. So that gets us our game manager object. Now we need a game manager script. So we're going to come over here to Visual Studio, back to scripts, and we're going to add a new item. Again, it's add new item. Unfortunately, new item shows up off the screen on this. I'm going to select a new Unity mono behavior, and I'm going to call this script Game Manager. Now this is where things come in handy. Is like going with this template in place, I've already fleshed out a nice little method of bringing stuff in and keeping it organized. In this case, the game manager is going to be fairly simple, and we're not going to use any properties, so I can get rid of that. We're also not going to rely on the awake method in mono behavior, but we will be using the start and the update inside of the game manager. So with that, we've got the skeleton in place for the game manager. We can save that, come back over into Unity, and then take our game manager script, drag and drop it on top of game manager, and now we've got game manager script in place. So we have the framework in place for the game manager, and we can start building from there, which is what we'll do in the next video. See you next time. Welcome to the next video in this series. In this video, we're actually going to get a sprite up on the screen for the first time. But before we do that, I want to do a little bit of cleanup work up here. What I want to do is I want to come in here and create a new empty game object, and I'm going to name this level. Now, the reason I'm creating this is I want to parent both of the walls and all three of the floors to this empty object. And all that it is doing is it's giving us one transform, so I can move everything all together at one time, or I can move it, I can rotate it, I can do anything I want with it. But the other advantage is it just allows me to collapse it and get it all out of the way. It's just something really, really simple, just to keep it nice and tidy. Let's see. Oh, that's pretty much all I want to do with that. The next thing that we need to do is actually get a sprite on the screen. Now, the first way I'm going to do it is the way you can do it that's built into Unity without using any of the additional scripts that we put in here. All this SpriteManager stuff. We're going to skip that for now. We're just going to do it natively with Unity. To do that, we're going to come up here and we're going to create another game object. This time, though, instead of creating an empty one, we're actually going to create a plane. So that's going to bring our plane in, which is going to come in at some arbitrary location. So we want to zero it out. And you'll also notice that it is facing straight up in the y direction, or its local z. So to fix that, we can rotate by either -90 or 270. Both yield the same result, and it will. So I'm just going to go with 270 to keep it in positive numbers. You'll also notice that this is an awfully big sprite, and our basketballs were kind of small, and we don't really want a basketball this big. So luckily, the numbers work out that if we reduce all the scales by 1/10 to 0.1, we get just the right size. So that's what I'm going to go with. I'm going to move it up a little bit so it's not stuck in the center. And from here, we have our sprite. Well, it's not really a sprite, it's actually a mesh, just a plane, but we're going to turn it into a sprite. So to turn it into a sprite, we need to add a texture. So we're going to create well, actually I'm not going to create it, I'm going to drag and drop it. So what you need to do is go out and find yourself a nice image of anything you want to turn into a sprite, and copy it and then just drag and drop it in. You can also right click and hit import new asset, but I just drag and drop it, and mine happens to be a basketball. So that's my texture that I'm going to use for my sprite. Now to apply it to our plane, we need another material. So what I'm going to do is I'm going to create a new material, and this material I'm going to name it ball mat for ball material, and then I'm going to drag the basketball texture into our texture, and then from here I'm going to take our ball material and I'm going to drag it and drop it on our plane. So now we've got our ball, but it looks kind of funky and it's not exactly right. Reason why is the shader that we're using is diffuse, and again it's looking for a light, which we don't have. So what we're going to do is we're going to go back to particles and we're going to change it to an alpha blended texture. So with the alpha blending and it being a particle, it doesn't need any light, and it detects the alpha that I added from using a image editing program like Photoshop. So now I have an alpha basketball even though it's a plane. So now this is our sprite. It's not a true sprite in the tradition of the sense where you're drawing directly onto the final image. We're actually rendering a texture via material onto a plane, and that plane is being manipulated in 3D geometry. So technically, if you really want to get down to it, everything we've done here, even though it's a 2D game and it looks like we're using sprites, it is still truly 3D. We're just fooling the system and making the believer think that it's a 2D sprite-driven game. So it's a gray area, and we're definitely kind of graying the borders, as it were. But it does work. So what you end up with now looks like a basketball. But let me save this real quick just in case Unity wants to crash again. And if we hit play, notice it doesn't do anything. It just kind of sits there. Well, the reason why is we haven't set up any physics on our plane. So we're going to go up here, and I'm actually going to rename the plane, and I'm going to name it ball. So now we've got it, and you notice it does have a collider, but it's a plane collider, and that's not really going to work for us because it's a ball. But to show you what I mean, I'm going to leave it for now. But we're going to come in here and we're going to add another component, physics, and we're going to make it a rigid body. So now what we've got is we've got a rigid body applied to our basketball, and I'm going to set its mass to 10. It's going to use gravity, so now our ball should fall. So what I'm going to do is I'm going to move it up a little bit and come over here, save again just in case, and then hit play, and our ball bounces. But notice it didn't do anything. It just kind of fell through, didn't interact with anything. So to do that, let's go through here. So what I'm going to do is I'm going to take the ball up here, click on the right thing, and I'm going to get rid of our mesh collider, and I'm going to remove that. I'm going to come up to component, I'm going to come to physics, and I'm going to add a sphere collider. Now if I zoom in here, you can see that our sphere for our sphere collider lines up almost perfectly with our ball. Close enough that in this type of game you'll never notice the difference. So we're going to leave it that way. So I'm going to save it again and hit play. And now that we've got a sphere collider, it actually interacts with our plane, or with our cubes that we've turned into floor surfaces. So that's what I wanted to show with that. So now we've got it interacting. Now, one of the things that you've noticed is it didn't really bounce. It just kind of fell and stuck and rolled. Now, if you want to make it bounce, we need to add another material. The material that we need to add, though, instead of being a regular material, is actually a physics material. So a physics material just basically defines how it's going to relate, or how this sprite is going to react physically. So what I'm going to do is I'm going to rename this as a bouncy mat for a bouncy material, and I'm going to come up here to its bounciness and I'm going to set it to 1. Now 0 means no bounciness, 1 means maximum bounciness. So just by setting this to 1, and I come over here, save again, and hit play. Oops, notice just because I made a bouncy material, it isn't applied yet because I didn't apply it to the sphere collider. So I need to take this, drag and drop it to the material for the collider. This is how you define how this collider is going to react when it hits another surface. So now when I run this, we should get a nice bouncy basketball. So now you notice indeed our basketball is bouncing. But you may notice that the quality of our texture isn't as good as it could be. So let's look at that right now. So we can go into basketball. We can come in here and look, and it's going up. Well, it's using bitmaps because it's 2D, and we're not going to have stuff way off in the distance and stuff really close to the camera. We can get rid of bitmaps. And let's set this to trilinear filtering to get a little bit better filtering on it. So we hit apply. I'm going to save it again, run. Now you can see we've got a much crisper looking basketball. And it is rolling and bouncing. Now, if you remember, we're not even using the Sprite Manager yet. This is all done with just a plane modifying its collider to be a sphere and adding a bouncy material to it. So if we're looking at the stats, we can see that we've got 6 draw calls. So we've got 1 for each one of the cubes plus 1 for the basketball. And what I'm going to be showing you in the upcoming videos is what happens when we take this basketball and we're going to turn it into a prefab, and then from there we're going to make multiple copies of it. And then once we've got that going, you'll see how that acts with the draw calls and how it will increase the number of draw calls, which can cause a problem when you're developing on the iPhone. So with that, that is all I wanted to show you in this video. And in the next video, we will go and turn this into a prefab and get multiples of them on the screen at once. See you then. Welcome back. In this video, we're going to take our basketball object and we're going to turn it into a prefab. Now, the reason we want to turn this thing into a prefab is that we want to have multiple copies of the ball in play all at the same time. So the easiest way to do it is to take the ball that we've created, turn it into a prefab, and then we use that prefab to be used in our game manager script to instantiate multiple copies. And theoretically, we could take that prefab and instantiate so many copies that we ran out of memory. We're not going to do that. We're just going to create 5, but you could if you really wanted to, and it would really slow down your system. But it is kind of fun to play with and add, say, 50 or 100 basketballs and watch them all bounce around. All right, well, let's get started. To create a prefab, we're just going to go to our prefab folder. We're going to right-click, and we're going to create prefab. This is going to give us our new prefab object, and I'm going to rename it, and I'm going to call this Ball Unity Prefab. Now the reason I'm going to call it Ball Unity Prefab is in later videos we're actually going to have another prefab that is going to be based off the Sprite Manager and I want to be able to switch back and forth between the two. So that's why I'm going to name this one Ball Unity Prefab. Now, to create this prefab, or to get it working, all we have to do is come up here to the ball, drag it down, and drop it on top of the ball prefab. That's it. Now, if we want to use it, we can come up here, we can delete the original ball, we can take the ball prefab, and we can drop it in, and we've got our ball. Matter of fact, I can drag another one in, and then I can move this one, say, over here. And if I wanted, I could even drag a third one in, and then I can put that one over here. Now, let's go ahead and save this. And if we play, what you see is all three balls work. They all have physics applied to them, and they all bounce and react differently based on their initial position that starts. And that is all there is to setting up a prefab. So in the next video, what we're going to do is we're going to write the code in the script that is going to instantiate these copies of the prefab in code, so we won't have to drag and drop them. So what I'm going to do is I'm going to delete out these, or delete those prefabs out for now, and in the next video I'm going to show you how to code in the instantiation of those prefabs. See you next time. Hello again. In the last video I showed you how to turn the ball into a prefab and then to manually make duplicates of it and put it into your scene. In this video I'm going to show you how to pragmatically code the instantiation of those prefabs. So let's get started. What we're going to do is we're going to go to the game manager and we're going to open it up in Visual Studio. Now there's going to be a couple of things that we need to do to be able to instantiate the prefabs. So the first thing we need to do is we're going to need a public game object, which is going to hold the reference for our prefab. So I'm going to create that field now. And the other thing that we're going to need is we're going to need some sort of structure to hold all, or a reference to all the instances of that prefab that we create. So to do that, I'm going to use an array list. So I'm going to create an array list, and I'm going to call it balls, and I'm going to initialize that to a new array list. Now for our fields, that's all we're going to need right now. Now the next step is we actually need to instantiate a prefab in code. To do that, what I'm going to do is I'm going to create a method, and I'm going to call, well, first I got to type it right. I'm going to call that, or I'm going to make it a private method. It's going to have a return type of void, and I'm going to call it add object. And in this case, actually, I'm going to call it add unity ball. And the reason why I'm going to call it that is because I want to prepare for in the future when we actually have the SpriteManager prefab in place, and I'm going to have a different method for instantiating that, and you'll see that in upcoming videos. But for now, we're going to just call this initial method add unity ball. Now what I need to do is pass a couple of arguments into it. So the first one I want is going to be a game object, and I'm just going to call this game object, let's see, what do I want to call this one? No, I'm actually going to call it, let me make sure that I do it the way I want. Actually, I'm not going to do that at all. What I'm going to do is I'm going to pass in a vector, 3. And that vector I'm going to call position. What I was originally thinking was passing in the prefab, but because we've already got a field that's going to be our prefab, I'm going to leave that alone for now. And I'm going to rely on the fact that that public field is populated with the proper prefab. And I'll show you that here in a sec as well. But we're going to need a position. The reason we need a position is to instantiate a ball, we need to pass in certain values into that function. And to do that, what we're going to do is, let me get this set. What we're going to do is we're going to, let's see, what's the easiest way to do this? Let me think about that. What we're going to do is I'm going to make a game object, and I'm going to call this game object temp geo for temp game object, and I'm going to make that and instantiate of the ball prefab, and the next argument is our position, because it's looking for a vector 3 position. You can see that the original is the object, second argument it takes is a position, so I'm going to give it position. The third is a rotation. Now in this case I'm going to set it up to be the quaternion identity, so I really don't want any rotation on it whatsoever to start off with. So that's going to give us our initial instance. But because we're instantiating and it's a game object, what Unity wants us to do in, when using C# is to cast that, cast that as a game object. So what's happening is we're instantiating based on the ball prefab, giving it a position and a rotation, and it's going to return out a game object. We're casting what it returns as a game object and assigning it to temp geo. Now the whole reason I use the temp geo or temp game object is because of an issue when we actually created the initial ball. Let me show you that real quick. If you remember back towards one of the very first times that we were when we first created this, and we were creating the initial ball and we brought in the plane, we had to rotate it because it was initially at a rotation of 0. As you can see, if we have a rotation of 0, you're not going to be able to see the plane because it's facing upwards. So what we did is we rotated that to 270 so it was facing correctly. Well, that's going to present a little problem here in code. Now, when we're in the code, the problem that it's giving us is when we instantiate the ball prefab and we give it a position and we give it the identity for its rotations, we're zeroing out all the rotations. So we're losing that rotation of where it was at 270. So to get it back, what we have to do is take the temp geo, we have to get its transform, and then we have to rotate. And then what we rotate is a new vector. So we just do new vector. New vector 3. And we give it a rotation of 270 in the x by 0 by 0. And what that'll do is that will re-rotate the object so it's facing forward again. Once that's done, we've instantiated the object, we've fixed its rotation again. We need to add it to our array list up here called balls. So what we're going to do is we're going to go to balls, and we're going to add, and what we're going to add is going to be the temp game object. And let me close off that. So after we've done our rotation, we've added the ball to our array list, and that is what we need for the method for instantiating a new ball. But right now we've got the method, but nothing's calling the method. So what we're going to do for that is we're going to come up here to the start, and we're going to use a for loop. So we're going to use the for loop, and I'm going to just use the standard integer I equals 0, And while I is less than, in this case, I'm going to use 5, so we get 5 balls to start, and then I'm going to increment I. Now, from here, all we have to do is add the unity ball, and we're going to pass in its position. Now, for a position, I'm going to use new vector 3, and I'm going to give it a position of -5, and then I'm going to use a little formula here, which is going to start off at 7 in the Y position, and to that I'm going to add I times 2 units. So what I'm doing here is I'm going, for each iteration of I, when I is 0, I'm not going to be adding anything to 7. But when I is 1, I'm going to add 2 to it. So the next ball is going to start 7, or first ball is going to start 7 units above the bottom. The second's going to be 9. The third's going to be 11, and so as long as we go. The whole reason of doing that is so when we instantiate the balls, they don't all start at the exact same position and collide with each other right off the bat. We don't, because it's a 2D game, need a Z depth, so I'm going to set Z to 0. And I'm going to finish off that line of code. So that should be all the code that we need to make 5 instances of the ball. So I'm going to save that. I'm going to switch back over to Unity, and I'm going to save my changes here just in case something bad happens, and then I'm going to run the code and see if it works. So as we can see, I've got an error. It says prefab you want to instantiate is null. And the reason that is I've added the code to the game manager here. The game manager script here is associated with the game manager here, but I made a public field for prefab. But what I forgot to do was come in here and associate the prefab with that object. So what I need to do is go and grab the ball unity prefab, drag and drop it into this field, and now when I run it, let me save again. When I run it, we should see the balls, and here they come. So now we've got 5 balls going and all flowing down. Now one of the things I want to point out is if we look at the stats, we've got 10 draw calls. We've got the 5 draw calls from the scene, or the level itself, and then we've got you noticed a little funkiness there. I'm going to explain that in a sec. But what we've got is we had 10 draw calls, but we've lost a couple of the balls, and the 5 were for the scenery and 5 were for the balls themselves. So that's what we're trying to do, is streamline the number of draw calls. Now let me explain what just happened, and I'm going to do that by closing stats. I'm going to pause it or stop it. I'm going to play it again. This weirdness that we're getting with the balls falling off and kind of pancaking and doing some really bizarre stuff is all because of the way the physics work. And what is happening is, if you remember, we're using a sphere collider. So the sphere collider actually is a 3D object where we just have a sprite, make it look like a sprite. So if we come up here, and let's see, I'm going to see if I can get the camera in a position so we can see what's going on. If I start playing this and then I pause it oops, sorry, I meant to hit pause. Alright, so if I pause it real quick and I select these and we zoom in, you can see that they're 3D spheres and that they're rolling along the edge. And this also presents an interesting problem. Our level isn't zeroed out correctly. So let me stop this animation. I'm going to grab our level, and let's move our level over some. Let's see what's going on and make sure our prefab. So that's what's happening. Our level was zeroed, and I'm going to zero it again. Sorry, Control Z, Let me select the level, and I'm going to zero it out. Alright, so now the level's zeroed out. Let me get our prefab. Our prefab is what's not zero. It's actually a little bit off. So we're going to go here. I'm going to zero out the prefab. Alright, now if I play this and then pause it, let's see what we've got going on. We're still alright, so all my stuff inside my level is not zeroed. Gotcha. Alright, so all the stuff inside the level isn't zeroed as well. So let me zero out everything inside the level again. There we go. Let's reposition the camera. So now the level is all zeroed out. So the very center of each level is actually along its center. Then if we select all the balls in the scene and zoom up on them, you can see that they're actually 3D spheres. And as they're rolling, they're not necessarily staying on the grid. They're moving in depth forward and backwards. And then you can see right here where they're rolling off, and they're not just constrained to roll just on the Z. And the reason why is the physics doesn't know that we want to stay locked in the Z direction. So we need to accomplish a mechanism for fixing that. So to do that, we need to go back to the ball prefab. Let's close some of this other stuff down real quick. And I'm going to close that down and close the material down. Now, to fix it, what we need to do is somehow constrain these sphere colliders so they don't move in and out in depth closer and further away from the camera and roll off of our level. So to do that, we need to add another component. The component that we're going to add is going to be the configurable joint under physics. So we add that, and we come in here, and what we want to do is we want to lock the Z motion. So what we're going to do is we're going to change Z motion to locked. But if you looked at the way the prefab is made, it's not necessarily going to line up with the world Z. We've got X here, we've got Z here, and Y there, but that's not always going to be the case because we've also rotated the mesh inside of 270 degrees, so it may or may not work the way you would expect. So what we're going to do is we're going to tell it to configure these constraint or this locked Z motion to be in world space and not the object space. So with that, I can delete there, and we can make sure, oh, I selected up here, I need to select it inside the prefab itself. So inside the prefab, we've got to make sure that our configurable joint Z motion is locked and configured in world space. So now when we run this, we should see what we expect, which is all the basketballs working, bouncing around, interacting, but staying locked in depth. So they're not moving forward or backwards, and they're not going to roll off of our level. They're going to stay where they are supposed to be. And it looks like I've still missed a couple. So let me fix this up and see what I'm still missing that's not zeroed. So I've got that one that's not zeroed. I think what may have happened, and I'm pretty sure what happened, is when I redid those positions, I was in paused mode and I wasn't actually stopped. So what happens is when you make any change in the game is currently playing and you stop that, any change that you made is going to be lost. and I'm pretty sure that's exactly what happened. So now I've got the whole level zeroed out in depth, and it looks like I finally have all the individual components of that level all zeroed out in Z or Z, depending on where you're from. So now that I've got all that done, I'm going to lock it. Our prefab's all set, and our simulation runs, and our basketballs do not fall off the level. So, and let's see, with that, that should be all we need for this video. Once again, you can see that draw calls are 10. So that's going to be it for this video. In the next video, we're going to start setting up the Sprite Manager to accomplish the same thing that we've got here. So I'll see you then. Welcome back. In this video, it's time to actually start messing around with the Sprite Manager. So what we're going to do is a little bit of prep work. The first thing that we need to do is we need to get another prefab all set up that is actually geared for working with the Sprite Manager. So what we're going to do is we're going to create a new game object. It's just going to be an empty game object, and I'm going to name this game object, let's see, I'm going to name this one just ball. Just like before, we're just going to put a couple of things in place. It's just a transform at the moment, and I'm going to zero it out, and we're going to add a couple of things to it. What we need to add for it is going to be a sphere collider, and we're going to need a physics rigid body. From there, we need to add a couple of things to it. What we're going to need to do is come up with the sphere collider. We're going to want this ball to be bouncy. So we're going to take our bouncy material and we're going to drag and drop that onto the material. The other thing we want to do is set the mass to 10 to be consistent with our other prefab. And that, I believe, is basically everything we need to do for the initial work of this prefab. So what we need to do is turn it into a prefab. So we're going to come down to the prefab folder. We're going to create a new prefab. We're going to name this prefab ball Sprite Manager. So I'm going to use SM for Sprite Manager Prefab. So we've got a second prefab. And as you can see, it's gray because it's not actually a prefab yet. So I'm going to take the ball, I'm going to drag it down, I'm going to drop it on this prefab. So now I can delete this one. I've got this prefab. I'm going to drag it up here so we can look at it. Now, if I zoom in on it, you can see it's pretty much empty. There's nothing in it. And the reason why is because we're using the Sprite Manager, so the geometry is going to be created at runtime via the SpriteManager, the SpriteManager Script or the LinkedSpriteManager, whichever we decide to use. So there is no geometry. We don't have any mesh renderer to render it. That's all going to be calculated dynamically. What we do have, though, is a sphere collider because we still need to interact with the level and we need to have it bouncy, so we've got the bouncy material. So with that, we've got the initial work for our sprite in place, and in the next video we're going to set up the Sprite Manager to take advantage of this. So I'll see you then. Hello and welcome back. Well, it's time to finally set up the Sprite Manager. It's been a few videos to get here, but we're finally here. So what we're going to do is we're going to create another game object, another empty one, and we're going to name this one Sprite Manager. So here's our Sprite Manager game object. Now what we're going to do is, if you remember in one of the first videos, I mentioned that there's two different managers. There's the Sprite Manager, and then there's the LinkedSpriteManager that inherits from it. The Sprite Manager, it basically will draw a sprite, but you're required to update that sprite if you want its position to change. Whereas the LinkedSpriteManager will automatically readjust its position based on its parent, or it's not so much its parents, but its associated object's position. So to start with, what I'm going to do is I'm going to create the Sprite Manager. I'm going to associate it with just the Sprite Manager and not the LinkedSpriteManager. So what we're going to do is we're going to take the Sprite Manager and I'm going to drag this up to the Sprite Manager. That's going to associate the Sprite Manager script with the Sprite Manager game object. And if you look, it's actually looking for a material. The material that it's looking for is going to be the material of the sprite that you want to use. In this case, we want to use the ball material. So we're going to drag the ball material up to the material section. So now the Sprite Manager has what it needs to begin its initial functionality. The way to think of it is the Sprite Manager is the Sprite Manager game object is the container and the transform for the Sprite Manager script. If you remember, I mentioned that the way the Sprite Manager works is it takes and creates a quad for every sprite that you add to the Sprite Manager. It then takes all of those sprites and puts them together and builds a mesh from it. That Sprite Manager and that mesh in the Sprite Manager script is going to be associated with the Sprite Manager, and its position is going to be relative to this Sprite Manager's transform. You'll see that a little bit later on. But because of that, it's very important that we take the Sprite Manager and make sure that its positions are all zeroed out, its rotations are all zeroed out, and its scale is all set to 1. If it's not, you could get some very bizarre behavior with the sprites. So you want to make sure all of those are set to either 0 for position and rotation or 1s for scale. Once all of that is done and is in place, then you're ready to go on and start to set this up, which is what we're going to do in the next video. So I'll see you then. Hello and welcome back. From the last video, there was one thing I forgot to set when we were setting up the Sprite Manager. One of the things that we need to do is the alloc block size. Because I am going to be using only 5 for the basketballs, I'm going to allocate this to 10. Basically, it has to do with how much memory or how much of the memory is allocated for arrays for storing the quads that the Sprite Manager creates. So you don't want to go too large with this, because what will happen is it'll end up allocating too much memory that may or may not be used. But if you go too small with this number, it's going to be constantly reallocating blocks of memory, which could slow down performance. So by all means, go into the wiki, read up on this, and get a better understanding on how to pick the numbers based on the number of objects or sprites that you're going to be having the Sprite Manager draw. And with that said, let's move on to the next part of this. What we need to do now is to get the Sprite Manager to actually draw something. So what we're going to do is we're going to come in here to the Game Manager. Let's go to the Game Manager Script inside of Visual Studio, and we're going to set some more stuff up. One of the things that we need to do up here is we need another public method, or sorry, public field. And what we need to do is we need a Sprite Manager. So we're going to define a field called Sprite Manager of type Sprite Manager. And I'm going to use the lowercase s for this Sprite Manager. And that's going to create another field for us. And I'm going to save that. I'm going to jump back over here to Unity. And what that's done for us is under Game Manager, we now have a new field that's unallocated. But because we told it it's going to be of type Sprite Manager, we're going to drag our Sprite Manager into it. So now we've got our Sprite Manager associated with this Sprite Manager. Now from here we can go back into Visual Studio and continue on. Now from here what we need to do is we need a way of adding our game objects that are going to represent our sprites inside of Sprite Manager. So what I'm going to do is I'm going to copy this method and I'm going to duplicate it, and I'm going to rename it from add Unity ball to add SM for Sprite Manager ball, and I'm going to keep the rest of this part the same. We don't need the rotation because if you remember, the Unity ball is based on a plane which we had to rotate 270 degrees to face the camera. By default, all sprites that are created with the Sprite Manager are going to start off facing the camera, so we don't need to rotate it to achieve that effect. What we do have to do, though, is we have to tell the Sprite Manager to add a sprite for each game object that we pass into the add SM ball. To do that, what we do is we tell the Sprite Manager, the instance of the Sprite Manager that we passed in, to add a sprite. Now, from here, it's expecting a game object to be sent to it. So what we're going to do is we're going to cast in a game object, and that game object that we're going to cast in is the temp game object that we instantiated up here. The next thing it's looking for is going to be some information that deals with the texture that is applied to that sprite. Now, this initial float for width and the initial float for height that it's looking for is actually UV space. What it means is the texture has a UV space of 0 to 1. If we're using only part, or if we're using a texture atlas and we're only using part of that texture, we would use a smaller number than 1. But because our texture is our basketball and it only has that basketball on it, we're using all of that texture. So we're going to use the full UV space. So we're going to assign 1F and 1F for the UV height and width. Now the next thing it's looking for is the start position of our texture. Again, because we're using the whole texture, we're going to start our texture off at 0 and 0. And because we're using all of that texture, we need all of the texture's width and all of its height. And this particular texture that I brought in is 256 pixels by 256 pixels. So we're going to use all of that. Now, billboarding is referring to whether or not our sprite will always face the camera, no matter where the camera is pointed, whatever rotation, orientation, or position it's in. Because we're using an orthographic camera that's not going to move, and it's not going to rotate, and it's not going to move through our scene, we're not going to use billboarding, and we'll save some processing power by not having to calculate the billboarding part of it. From that's the only change we have to do. Now, to look a little bit closer what's going on here is every time this add SM ball is called, we're creating a new game object called temp game object, and we're passing that into add sprite. What add sprite is doing is it's adding a quad into the Sprite Manager. The Sprite Manager is building a mesh when this script is being run. We are actually going to be calling this add SM ball inside of this loop, which means we're going to be calling it 5 times. So what this is doing is it's going to add 5 quads to the Sprite Manager, and it's going to combine those 5 quads into a single mesh. That single mesh will only need a single render call to draw all 5 of those sprites. So what I'm going to do is I'm going to take this and I'm going to replace this method with the add SM ball method, which is going to bring all instead of sending the functionality here, is going to send the functionality to the add SM, which is using our Sprite Manager to draw the sprites. So I'm going to save this code, and I'm going to jump back into Unity. We still have another thing that we have to change inside of Game Manager. We've added the Sprite Manager to it, but our ball prefab is still pointed back to our ball Unity prefab. And since we're doing the Sprite Manager, we need to bring in our other prefab. So now we've got everything all set up. There doesn't seem to be any errors. And if everything works out right and I hit play, we should see some basketballs. Now, what's going to be weird is, depending on how close you are paying attention to the videos, they may not react the way you think. In other words, they're not going to fall, and they're not going to bounce, and they're not going to have any physics applied to them. And if you remember, that's because we're using the Sprite Manager for our Sprite Manager and not the LinkedSpriteManager. And as I said in an earlier video, the Sprite Manager by default is not going to update the position of the sprites based on their associated game objects unless we explicitly tell it to. So what's going to happen is the sprites are going to be drawn in their initial position, and then they're just going to stay there. But the game objects that are going to be created are going to continue to fall and rotate and act the way you would expect. But now that I'm thinking about it, there's something we forgot that we have in our Unity prefab that we don't have in our ball SM prefab, which is this configurable joint. And if you remember, the configurable joint is used for constraining the motion in depth. It's used for a lot of other things, but we're using it specifically for constraining the Z motion. So I'm going to go in here real quick. I'm going to set that to locked, and then I'm going to configure it in world space so it holds in depth like we expect it to. So I'm going to save those changes and see what we get when we play. So like I said, I hit play and then I just paused it. But what I want to do is I want to select all of these prefabs. And I'm going to zoom in here a little bit. Let's move this over. What you can see, that's a little bit weird. And if you look closely, what you can see is we've got our sprites, which our Sprite Manager is drawing. And then we've got all of these sphere colliders that are moving. Now if I unpause this and let the simulation run, you can see that all of our sphere colliders are acting the way we thought the simulation should. But all of our sprites are stuck up here. Now, why is that? The reason is actually because we're using the Sprite Manager, not the LinkedSpriteManager. Here's something that's kind of neat. If you click on the Sprite Manager, you'll see we get a transform. Now this transform is at the world Z, but it's also associated with these sprites. And if I move it, all the sprites move along with it. And the reason why is the Sprite Manager is associated with a mesh, and you can see it here. It's added its own Sprite Manager mesh filter and its own mesh renderer. This only happens at runtime. So what has happened is inside of the Game Manager, when we loop through that add SM ball method, and we've called SpriteManager.addSprite, it's added a quad for each one of these basketballs. It's then merged all of those quads into a single mesh, which is this Sprite Manager mesh, and that is what it's drawing. Now, what the Sprite Manager does is it renders it based on those vertice positions. But because we're not using the Linked Manager and we haven't told it to check for changes, it's not updating the positions of those quads in relation to our objects. Now to fix that, what we're going to have to do is go back and tell it to do it manually. And I'm going to show you how to do that right now. We're going to jump back into Visual Studio, and then we're going to come down here, actually up here to the update function. Now what we're going to do is I'm going to copy this for loop up here, and I'm going to bring it down here, and I'm going to paste it. But I'm not going to call the add SM ball because that would just create 5 more instances every frame. We really don't want that to happen. What we do want to happen though is we want our position for each one of these balls to update. But how are we going to do that? Well, if you look at the Sprite Manager and add sprite method actually will return a sprite. And that sprite is actually a reference to, in our case, one of those basketballs. So what we have to do now is we need to add a structure, or sorry, not so much a structure, but a data structure to hold that. So what we're going to do is we're going to create another array list, and we're going to name it sprites. And we're going to initialize it. Now we're going to populate it. We're going to come down here, and what we've done is where we've added our temp geo, we need to do something similar with our sprite. So to do it, what I'm going to do is I'm just going to type in sprites and dot add, and what I'm going to do is I'm going to pass in this entire line of code. So what this line of code is doing is it's going to add the Sprite Manager, or add a sprite to the Sprite Manager that is then going to return a sprite from this method, which is then going to be added to our sprites data structure. From there, I can come back up here to our update, and instead of doing add SM ball, I can do sprites dot let's see, what is it? It's sprites. Sorry, my bad. Sprites dot I dot let's see. Oh, I gotta cast it. What it's doing is it's not sure, because it's just an array of objects. It doesn't know what type of object. So I have to cast the sprites array, or this particular instance of this array, to a sprite, which should then allow me to update. And you would think it would. What did I miss? Oh, my bad. I'm thinking of it the wrong way. Close, but not exactly. I need to call the Sprite Manager, and I have to tell it to transform, and then I have to pass in the sprite that I wanted to transform. So from here, what I need to do is cast to type of sprite, and I have to pass in my sprites, the current instance, which is going to be sub I. So now what I'm doing is I'm telling it to loop through all 5 and get that sprite, cast it as type sprite instead of an object, and then transform it via the Sprite Manager. So what's going to happen is every frame, the Sprite Manager is going to update all of its sprites based on the associated game object that we sent it. So I'm going to save that, and if everything worked right, and I hope it did, I hit play, and our basketballs are going to react the way that we expect them to. And I've got an error. Sprite could not be found or missing. So what did I do? Something in the cast. Let's see if it works without it. Nope, definitely wants me to cast it. Cannot convert from object to sprite. So let me see what's going on here. may very well be it wants me to cast this as a sprite as well. So let me try that. You'll find that with Unity there's a lot of casting to enforce types, and still missing directive or an assembly reference. Give me a sec while I figure this out. Trying to figure out exactly why it does not see. Let's see what is going on here. Alright, let's see. Oh, I see it. Typo. I fat fingered it. Actually, it needs to be Sprite. That will probably make it a little bit easier. Alright, let's save that and see what's going on. Alright, so now that errors, listen. This error, don't have to worry about it. It's because we're actually still running the simulation. Alright, so go ahead and run. And as you can see, now it's updating relative to all the cloned prefabs. So it works the way we expect it to. Alright, so let's pause or stop that animation. And basically, that's all I really wanted to show you with this video is basically what happens when we use a Sprite Manager, what is actually going on, how the Sprite Manager is creating the sprites, and how they're associated with the Sprite Manager. And then the fact that if it's just the Sprite Manager, you're responsible for determining what sprites are moving and make sure that their positions are updated via the transform method call inside of the Sprite Manager. In the next video, I'll be going over how to get the LinkedSpriteManager working and the code needed for that. See you next time. Hello, and welcome back to what should be the last video in this series. What we're going to do now is go back to the Sprite Manager, and we're going to change it from using the Sprite Manager script to using the LinkedSpriteManager script. Now, because we're using the LinkedSpriteManager script, there's a couple of things that we're going to have to change inside of our Game Manager CS file. Basically, all that is removing the stuff from the update code. And the reason why we can remove it is, if you remember from previous conversations or the previous videos, that the LinkedSpriteManager intrinsically performs the transform operation on every sprite that's associated with it. So what happens is at every frame, it's going to reposition the vertices that make up the quads that are the sprites that are inside of that Sprite Manager. So instead of having to loop through all of your sprites in an update every frame, this will do it all automatically. So with those changes in place, we should be able to run it, and we still get the same result. We get our 5 bouncing basketballs, and they still respond to physics, and everything works just the way it's done all along. Now, one of the things to remember, and let me show you this as well, is when you're working with this, either the Sprite Manager or the LinkedSpriteManager, because it is adding all those vertices into a single mesh, it only needs a single draw call. So no matter how many sprites you've got, it's only going to use one draw call. Because at the end of the day, all those vertices that make up all the sprites go into this one mesh, which gets sent to this one mesh renderer, which results in just that one draw call. Now, the thing that you need to take into consideration, once again, with the LinkedSpriteManager, is you only want to use it for things that you know are going to be moving most of the time. In our case here, with these basketballs, they're using Unity physics, and throughout the entire playing of the demonstration, until they get to the very end, they're always moving every single frame. so we're not taking a performance hit by using the Sprite Manager. But if you're making, say, a giant Super Mario clone, and you have a whole bunch of blocks and static elements that are just there, and they don't move from frame to frame, if you were using the LinkedSpriteManager, it's going to redraw all of those vertices every single frame. Even though they're not moving, they're still getting repositioned and moved, and they're being moved back to the exact same location that they were originally. So you don't see any change in their position, but it's still performing all of those calculations, and that is resources that you are wasting trying to reposition things that aren't moving. So it's best to just use the Sprite Manager for things that are going to be static, and Link Manager or the Link Sprite Manager for the things that are going to be in motion. If you've got a lot of objects that are going to be in different states where they're going to be stationary sometimes and moving at other times, what you can do is encapsulate them into a class that is able to check their state and then knows whether or not it's moved. And if it's been moved, then have it call a transform on that sprite so that its position is moved. So you're in between. You've used static. Your static stuff doesn't move. You just use the Sprite Manager as normal. For stuff that's always moving, use the link. And for things that are moving partially or sometimes and moving at other times, use the Sprite Manager and then manually call the Sprite Manager transform to update those sprites. And with that being said, that is everything that I wanted to show you with setting up this demonstration using both the Unity and the SpriteManager scripts. There's one other little thing I want to show you. With working with 2D, you may have noticed this in the videos depending on the quality that you're looking at, but there's a lot of jagged edges along our sloped floors, and when we're playing, the basketballs do have some little bit of jagginess to them. Sorry, my bad. Let me pause that. So there's a way that you can fix this if you want a little bit better quality. If you have a fairly high-end machine and you've got processing power, graphic power to spare, you can come in and go to, let's see, quality. All right, why did it do it? Okay, quality and fantastic. All right, good. So now it's there, and we play, and our playback looks a little bit better. Again, apologize for me forgetting where that is, but I'm really tired. But with that, that's the end of this series. I hope you enjoyed it. It was a lot of fun to make.